Hi, I'm Carly, and today I will be teaching you how to use an equation to determine the average rate of change. This concept was first introduced to us in Unit 1, Functions and their Properties and Rates of Change. And the sample question I will be using today comes from the Nelson Advanced Functions textbook, page 78, number 11. Question 11 states that the population of a town is modeled by P of t equals 50t squared plus 1000t plus 20,000. Where P of t is the size of the population and t is the number of years since 2000. 11a wants us to use graphing technology to graph P of t. 11b wants us to predict if the average rate of change in the population size will be greater closer to the year 2000 or farther in the future, as well as to explain how we made this prediction using the graph. 11c wants us to calculate the average rate of change in the population size for each time period or time interval. 2000 to 2010, 2002 to 2012, 2005 to 2015, and lastly 2010 to 2020. Lastly, 11d wants us to evaluate our earlier predictions made using the graph by using the data we developed from answering Part C. 11a wants us to use graphing technology to graph P of t. For this, we can refer to the graph answer given in the textbook. However, graphing calculators such as Desmos and QuickGraph are also viable graphing technologies that after entering in the P of t equation will format the graph. Question 11b wants us to predict if the average rate of change in the population size will be greater closer to the year 2000 or farther in the future, as well as to explain how we made the prediction. Now that we have the graph, we can see that our graph is getting steeper as the values of t increase, therefore the rate of change will be greater farther in the future. This relationship is further supported with knowledge of a secant line. A secant line is a line that passes through 2 points on the graph of a relation. We must note that the slope of each secant line is equivalent to the average rate of change over each interval. So, after plotting two secant lines on the P of t graph, it is clear that the secant line of the points with greater t values also had a greater slope and therefore greater average rate of change than the secant line with t values closer to 2000 or the start of the graph. This confirms that the average rate of change will in fact be greater farther in the future as the graph gets steeper. Question 11c wants us to algebraically calculate the average rate of change in the population size for each of the following time periods or time intervals. Before starting this question, we should recall that P of t equals 50t squared plus 1000t plus 20,000, where we let P of t represent the size of population and let t represent the number of years since 2000. This information will be in red text on the screen for the remainder of this question. It is also important to know what the average rate of change is, as well as how to calculate it. According to the textbook, the average rate of change is the change in the quantity given by the dependent variable, change in y, divided by the corresponding change in the quantity represented by the independent variable, change in x, otherwise known as the basic equation for slope. It is important to understand, however, that our equation is in the form of f of x, or P of t in this case. Since we know this information, our equation changes. The textbook tells us that for a function where y equals f of x, or in this case P of t, the average rate of change in an interval, such as 2000 to 2010, is equal to f of x2 minus f of x1 over x2 minus x1. With all of this prior information, we can now determine a few steps that will help us solve each part of question C. Step number 1 is to state the given values. Since the change in x is always the change in the independent value and time is always the independent variable, we know that x1 and x2 in our equation come from each time interval. In this question, the change in x will always be the change in time, or the change in t. Note that t and x are interchangeable in the bottom line, however t in the equation represents the number of years since 2000. Therefore, in step 2, we must find our f of x1 and f of x2 values of our equation by finding our corresponding t values and inputting them into the P of t equation. Our last step is to plug in all of these found values into the equation to solve for the average rate of change. Let's now solve for part 1 of C. In part 1, the time interval is 2000 to 2010. Therefore, in step 1, we can state these given values as x1 and x2. In this case, I made x1 equal to 2000 and x2 equal to 2010. However, it does not matter which is x1 or 2 as long as they stay consistent in the final formula. For step 2, the yellow boxes indicate the steps in which x1 is used to find its corresponding t1 value, which is inputted into the p of t equation to find the value of p of t1. Although t is the variable for x in the p of t equation, the question states that t equals the number of years since 2000. Therefore, if x1 is equal to 2000, t1 is equal to 0 because 2000 is 0 years away from 2000. Once the value of t1 is inputted into the p of t equation, the value is 20,000. This is the value that is plugged into the p of t1 spot, or f of x1 spot, of the general AROC formula. Likewise, the blue boxes indicate where the value of x2 is used to find the corresponding value of t2, which is inputted into the p of t equation. Since the value of x2 is 2010, and 2010 is 10 years away from 2000, the value of t2 is 10. Once the value of t2 is inputted into the p of t equation, the value is 35,000. This is the value that is plugged into the p of t2, or f of x2 spot, in the general AROC formula. The third step is to plug in these values into the AROC, or average rate of change formula, and solve. In this case, the average rate of change in population size from 2000 to 2010 increased by 1,500 people per year. Note that a positive value indicates an increase and a negative value indicates a decrease. These steps are repeated for each part of 11C. Note that each step is indicated on each slide. Also note that there is one key difference in parts 2, 3, and 4 of question 11C. The x values in step 1 do not match the x values in the AROC equation in step 3. Notice that since t represents the x value in the p of t equation, we can use t as our x1 and x2 values as well in the AROC equation by converting our x1 and 2 values in step 1. This conversion is seen in step 2, where x1 corresponds to t1 and x2 corresponds to t2. These values are interchangeable as they both represent our x values and ultimately give us the same answer. However, we are only able to use our t values on the top line of the AROC equation, as they are substituted into the equation to find our y values, and the p of t equation uses t. Feel free to rewind and pause on parts 2, 3, and 4 of question C. Question 11D asks us to evaluate our earlier predictions using the data we developed from answering part C, or in other words, confirming our predictions from the graph. Therefore, we can conclude that since each consecutive time interval is farther away from 2000 and the average rate of change in population size increases with each time interval, the prediction was correct in that the average rate of change will be greater farther in the future. A demographer is a social scientist who uses statistics and numbers to study the size, distribution, and structure of human populations over time. A demographer would most likely be solving this problem in order to predict the behavior of a human population and how it affects people's well-being in years to come.